Visit systemsarchitect.io and codeguides.io. Subscribe and like this video. In this video, we'll be discussing automation in cloud systems design. Automation is an important part of cloud operations and delivery side in systems design. It means encoding and orchestrating deployments, scaling, and recoveries as software, not performing them by hand. The goal is not saving keystrokes. It is removing human error from repeated work. A human running 20 steps at 3 in the morning will eventually run 19. They forget the 20th. The same steps expressed in code run identically every time. Automation also covers reactions, not just actions you start yourself. What does that look like in practice? A system that grows capacity or replaces a dead node without being asked is automated too. Simple pipelines and large orchestrated platforms sit on the same idea at different scales. Whether a system can be automated is decided by its design, not by its tooling. A component that needs a console click to deploy has hard-coded a person into the critical path. Most outages follow a change, so the way you ship is a reliability decision. Recovery speed depends on this even more than deployment speed. Manual recovery takes as long as finding someone who knows the steps. Automation also changes what your team dares to attempt. When a release costs a day of careful work, you batch changes. Big batches are what make rollbacks hard. When it costs 10 minutes, you ship small and fail in ways you can understand. Infrastructure as code means your environments are defined in files under version control. Terraform, OpenTofu, and Pulumi are IAC frameworks that work across providers. AWS CloudFormation, Azure Bicep, and Google Cloud Infrastructure Manager are native to those platforms. The important property is declarative configuration. You describe the desired end state, not the steps to reach it. The tool compares that description against reality. Then it works out the difference itself. What makes that safe to rerun? That gives you idempotent operations. So applying the same definition twice leaves the system in the same place. A script that only works when run once is a script nobody trusts to run at all. Reproducibility follows, because a whole environment can be rebuilt from the repository. Review follows too, since a firewall rule change now arrives as a pull request. CI/CD pipelines are the assembly line every change travels down. Continuous integration means each commit is built and tested automatically, within minutes. The value is feedback speed. A defect caught at merge costs far less than one caught in production. Automated testing in pipelines earns the trust to remove human gates later. Order the stages by cost, so fast unit tests run first. Slower integration and security scans follow. Continuous delivery keeps every build in a genuinely releasable state. A human still chooses when to ship. Continuous deployment removes that gate and releases every passing build. Choose the level that matches the blast radius. GitHub Actions, GitLab CI, Azure DevOps pipelines, and Google Cloud Build all implement the same shape. Immutable infrastructure means you never patch a running server. You replace it. A new version becomes a new machine image or container image. The old instance is terminated. That removes the slow accumulation of one-off fixes that make servers unreproducible. Blue-green deployment automation runs a second full environment. Traffic switches over once it is healthy. Rollback then becomes a traffic change measured in seconds. Canary deployment automation sends 1 to 5% of traffic to the new version first. The automation watches error rate and latency. Then it promotes or rolls back on those metrics. Let the metrics decide, because an alarm beats a human watching a dashboard at midnight. The question worth optimizing is how fast you reach the last known good state. GitOps makes a Git repository the authoritative description of what should be running. A controller such as Argo CD or Flux reconciles the live system toward the committed files. Deployment becomes a merge. Your audit trail and your release mechanism become the same artifact. Configuration management fills the same role inside long-lived machines. Ansible, Chef, Puppet, and Windows PowerShell desired state configuration hold servers at a declared state. Manual changes made outside the system are called drift. Drift is where reproducibility quietly dies. Drift detection compares actual state against declared state on a schedule. Remediation either alerts a human or, more usefully, reverts the resource automatically. Policy as code applies the same discipline to rules. Open Policy Agent, HashiCorp Sentinel, or Azure Policy can reject an unencrypted volume before it ships. Autoscaling is automation reacting to load without a person in the loop. Autoscaling groups on AWS, virtual machine scale sets on Azure, and managed instance groups on Google Cloud all add and remove capacity against a metric. Scale on something that reflects user experience. Request concurrency or queue depth beats watching CPU alone. Orchestration is the layer that decides what runs where and keeps it running. Kubernetes is the common example. It continuously reconciles actual pods toward the declared replica count. Workflow engines orchestrate multi-step processes instead of containers. AWS step functions, Azure Logic apps, and Apache Airflow are the common ones. Why does that matter? They make retries, timeouts, and partial failures explicit rather than buried in application code. A long process expressed as a state machine can resume from the step that failed. Event-driven automation runs logic in response to something that happened, not on a schedule. A file lands in object storage, a deployment finishes, a security finding appears, then an action fires. Event routers carry those event-triggered actions. Amazon Event Bridge, Azure Event Grid, and Google Cloud Event Arc all do this job. Serverless automation is the natural implementation. A function only exists while the work exists. AWS Lambda, Azure Functions, and Google Cloud Functions give you glue code with no fleet to maintain. Automated runbooks are the other half of this. They turn a written procedure into an executable document. AWS Systems Manager Automation, Azure Automation Runbooks, and Ansible Playbooks all execute recovery steps identically every time. Start by converting the procedures your team already follows. A playbook that a machine can run is documentation that cannot go stale silently. Learn more at systemsarchitect.io. Like and subscribe to the channel and follow the playlist. Self-healing means the system fixes common failures with nobody involved. A failed health check removes an instance and the replacement launches automatically. Automated remediation extends that to non-obvious problems. It wires the fix directly to the alarm that detected it. Failover automation handles the larger case. It promotes a standby database or shifts traffic to a healthy region. Automated recovery is only real if you rehearse it. Untested failover is an assumption rather than a capability. Test it on a schedule with a game day or a chaos experiment. Platform engineering applies the same thinking to your engineers. A platform team builds self-service automation. What does that buy a developer? They provision a compliant environment from a template rather than filing a ticket. Backstage and similar internal developer portals expose those golden paths. The clearest return is reliability, since rehearsed recovery paths beat improvised ones under pressure. Mean time to recovery usually matters more to your users than how often something breaks. Operations improve because toil is caped. Toil left in place compounds year over year. Security benefits too, since patching by image replacement is faster and more complete. Cost improves through scaling that removes capacity as readily as it adds it. Scalability becomes an operational property rather than an operational. The underrated benefit is retention, because engineers leave jobs made of avoidable pages. Automation is an investment, and it can be made too early or too deep. Automating a process nobody has performed reliably by hand just encodes a broken process faster. Run it manually a few times first, then automate the version that works. Blue-green deployments double environment cost. A low-traffic internal tool is better served by a rolling update. Very early products are the honest exception here. A design changing weekly should not be frozen into elaborate modules yet. Rare and genuinely irreversible operations deserve a human confirmation step. Deleting production data is not a place to prove your reflexes are fast. Start with version control, a pipeline, and health check replacement. Then let observed toil choose what comes next. Automation means expressing deployment, scaling, and recovery as code so they happen identically every time without depending on a person to remember the steps. Its mechanics run from infrastructure as code and tested CI CD pipelines through GitOps, drift detection, and policy as code. They run out to auto scaling, orchestration, event driven remediation, and self service platforms. Automate the repeated and reversible work first. Rehearse the recoveries you rely on. Keep a human in the loop only where a mistake cannot be undone. Thanks for checking this out. Hope you learned something. Find a lot more articles and guides on both systemsarchitect.io and codeguides.io.